let S equals to omega 1, omega 2 up to infinity. This be a sample space associated with a random experiment. Probability of omega n, this is half of probability of omega n minus 1, where n is greater than or equal to 2. A is the set containing these elements. A is containing all the elements of this form 2k plus 3l, where k and l, these two are natural numbers. B is the set containing omega n, where n is taken from set A, n belongs to A. Then we have to find the probability of this event B. Now, in this problem, there are a number of relations that we have to decode. The very first one is that probability of omega n. This is half of probability of omega n minus 1, where n is more than or equal to 2. So let us say probability of omega 1, this is some constant k. So that means probability of next event omega 2, this will be half of probability of omega 1. So this will be half of k. Similarly, the probability of this event omega 3, this will be half of probability of omega 2. So that means you will get 1 by 2 square and this multiplied by k. And in this manner, it will continue up to infinity. Now, omega 1, omega 2, these are events of a sample space, right? So therefore, sum of the probability of all of these events must be 1, right? Probability of omega 1 plus probability of omega 2 to infinity, that must be 1. So if I add all of these probability and if I take k common, then you will get 1 plus 1 by 2. Next term will be 1 by 2 square. Probability of omega 4 will be 1 by 2 cube into k. So 1 by 2 cube up to infinity. This sum must be 1. And now we have infinite GP, for which we have standard formula A by 1 minus R. A is 1, common ratio is 1 by 2. So this sum will become 2, right? 1 by 1 minus 2, that will be 2. So from here we are getting 2k as 1. And that means the value of k, this will be 1 by 2. So probability of omega 1, this will be 1 by 2. Probability of omega 2, this will be 1 by 2 square. Probability of omega 3, this will be 1 by 2 cube and so on. And in fact, if you want, you can write the general formula that probability of omega n, this will be 1 by 2 raised to n. So this is the first information that we got from here. Now the second relation that we need to decode is that set A contains all the elements of this form 2k plus 3l, where k and l, these two are natural numbers. So let us say what are the different elements present in this set A. Right, in set A, the different elements will be, if I talk about the smallest element present in set A, we can take k and l as 1 and 1. They are natural numbers, so the least value of k will be 1 and least value of l is also 1. So that will give us 3 plus 2, that is 5. Now the next element that we can create is 6. You cannot create because if I take l as 2, k will have to take 0, but we cannot take 0. Least value we need to take 1. So the next smallest value will be, if I take k as 2 and l as 1, then 2 into 2 plus 3, that will be 4 plus 3, 7. So this is the next element of set A. After this, if I have to create 8, you can take L as 2 and K as 1. So 3 into 2, 6 plus 2, that will be 8. And after this, all the elements you can create. For example, if I need 9, you can take K as 3 and L as 1. So 2 into 3 plus 3, that will be 9. If I need 10, you can take K as 2 and L as 2. So 2 into 2 plus 3 into 2, that will give us 10. So in set A, we have all of these elements starting from 5 up to infinity except 6, right? Now, B is the set containing all these events omega n, where n is taken from set A. So that means B is omega 5, then you have omega 7, omega 8, and in this manner it will continue up to infinity. And now the question is, what is the probability of this event B? So sum of all the probability starting from 1 up to infinity, this will be 1. So if I need probability of event B, this we can say is this will be 1 minus probability of, and all those events which are missing in this set. So 1 minus probability of omega 1, I mean 1, 2, 3, 4, those 4 terms are missing, and then 6 is missing. So probability of event B, this will be 1 minus probability of omega 1 plus probability of omega 2 probability of omega 3 plus probability of omega 4. 5 is there, and starting from 7 up to infinity we have all the terms, but the term 6 is missing, so probability of omega 6. So this should be probability of event B. Now this will become, for omega n we have this formula, that probability of omega n, this is 1 by 2 raised to n, right? This we have established earlier, that probability of omega n is 1 by 2 raised to n. So now for omega 1 the probability will be 1 by 2. For omega 2 it will be 1 by 4. For omega 3 it is 1 by 8. Omega 4 1 by 16, and omega 6 that will be 1 by 64. So this will be the required probability. Now you can do the calculation. After calculation you will find that this number will be 3 by 64, and therefore that should be the correct answer. Right, so in this problem, the important concept was that probability of sample space, that will be 1. So if I add all these probability, that sum should be 1. From there, we got the value of k as 1 by 2. And then we established that probability of omega n 1 by 2 raised to n. And then in set A, we have all the natural numbers except the numbers from 1 to 4, and then this number 6. So in set A, we had these elements starting from 5 up to infinity except 6, and B was this set. And finally, after calculation, probability of event B, this was 3 by 64, and therefore correct answer will be option D.